Swayam Prabha. Digital India. Educated India.
Next, we have the third speaker for today. These sessions will continue with two other virtual presenters. A third paper for these sessions is to be presented by Danush Maji. Danush Maji will be presenting on the optimal field selection using multi-criteria decision-making framework. And this paper is coming from India as well. I should say this is from Birla Institute of Technology and Science, Pilani. I believe the speaker is with us online. We can get the speaker to kickstart his presentation now. Danush, the floor is yours. Let me remind you, you have 15 minutes.
Good morning, everyone. I'm Danush Maji from UG student at Department of Chemical Engineering, which Pilani, Hyderabad campus. I'm going to present my work on optimal fuel selection using a multi-criteria decision-making framework. So the rising demand for energy as a result of population increase, standards of living has resulting in an extensive utilization of fossil fuels. However, like now, many fossil fuels are now creating a variety of emissions like hydrocarbon, carbon monoxide, carbon dioxide, smoke, and particulate matter. The majority of the alternative fuels which are now being developed throughout the world are either economically unfeasible or still in the process of the development. So here we can see the diesel, which is most popularly used in India. And now let's go to vegetable oil, which is used as the diesel substitute. This is highly viscous and also clog the filters, and also it causes the deposits in engine, which limits its usage in engines. And now biodiesel, which is this is obtained when vegetable oil is trans-esterified. So this is also used as a diesel replacement nowadays. But biodiesel is vulnerable to oxidation because it has deterring effects on polymeric constraints of engine at high temperature, which may lead to the stark operational problems. Now alcohols, which are another class of diesel replacement. These are uneconomical and often show poor visibility with diesel. Now water, which is used at very low percentage because it helps in improving combustion and reducing emissions. So what would be the best possible alternative? Microemulsions are developing field of alternative fuels which are thermodynamically stable with better performance and emission characteristics. Now let us have a brief discussion on MCDM, which is known as multi-criteria decision-making framework. So an optimal fuel selection becomes critical while evaluating the fuel based on several performance and emission characteristics. Multi-criteria decision-making MCDM is an effective tool for solving problems with multiple criteria and objectives. MCDM is based on the relative importance of particular criteria with respect to other criteria. What's the objective or novelty of our study? Our work is focused on choosing an optimal fuel from a pool of 16 fuel samples consisting of 15 different butanol diesel water microemulsions with 57.8 to 80 volume percent diesel, 19.6 to 40 volume percent butanol, and 0.2 to 2.2 volume percent water and diesel. In order to select the optimal fuel that can be used in a 100% engine load, MCDM techniques are employed to rank the microemulsions based fuel along with the diesel. 16 alternatives are expressed by the performance and emission criteria, and we conduct a thorough review in order to estimate which criteria to be taken. So 7 criteria are used to rank 16 fuel samples using HP Topsys and HP Promptly methods. So now let us look at the performance and emission parameters used for the ranking of the fuel samples. So this is the overall chart of the classification. So the fuel samples are evaluated and ranked based on the performance and emission parameters. The performance parameters include calorific value, brake thermal efficiency, brake specific fuel consumption, while the emission parameters includes emissions of carbon monoxide, hydrocarbon, oxides of nitrogen, and particulate matter. It is highly desirable to have a high value of calorific value of the fuel, which resulted in high brake thermal efficiency value. On the other side, brake specific fuel consumption BSFC, carbon monoxide CO, and oxides of nitrogen and particulate matter tend to be low. These are the components of the micromercial fuels used for ranking. So now let us look at the performance and emissions of alternatives at 100% load. So this is the decision matrix which is used for the our project. So the fuel properties were determined as per standard specifications of diesel fuel oil, and the performance and emission were monitored by running the fuel in a constant speed diesel engine. Now let us have a detailed discussion on the MCDM techniques which I used. Analytical hierarchy process, AHP. It is a technique used to find the weights for each criteria. Now let us have a detailed look on step-by-step procedure. In the step 1, we calculate the relative importance of each criteria with respect to other criteria, which helps us obtain the pairwise comparison matrix. So using this pairwise comparison matrix, we obtain the normalized pairwise comparison matrix using the equation 1, where M denotes the number of alternative and represents the number of criteria. In step 3, we will calculate the weights of the criteria. So now the question is, these weights are consistent or not. So in order to check for that, we'll have a look at it. So these weights are multiplied with the pairwise comparison matrix to obtain the weighted pairwise comparison matrix using equation 3. So from there, we'll calculate the weighted sum values and lambda max value using equation 4 and 5. So now we'll calculate the value of consistency index and consistency ratio using equation 6 and 7. So the value of random index depends on the number of criteria involved in the problem under investigation, which is determined with the help of this table, where n denotes the number of criteria. So if the consistency ratio is found to be less than 0.1, the degree of consistency is considered to be satisfactory, and the criteria weights obtained from the AHP method can be used within the MCDM framework. Now let us have a detailed look on TOPSIS method. It is a distance-based MCDM method, which is based on the idea that the chosen alternative has the shortest Euclidean distance from the ideal best solution and the farthest Euclidean distance from the ideal worst solution. Now let us have a detailed look on step-by-step procedure. So in step 1, we'll calculate the normalized matrix with the help of the decision matrix, which we have seen earlier. So from there, we'll calculate the normalized weighted normalized matrix with the help of the weights obtained from AHP method using equation 9. So from using this weighted normalized matrix, we'll calculate the ideal and negative ideal values for every criteria. So for beneficial criteria like CV value and BTE, so ideal and negative ideal values are the maximum and minimum values respectively, whereas for the non-beneficial criteria like emission parameters, ideal and negative ideal values are the minimum and maximum values respectively. So from there, we'll calculate the separation measures using the concept of Euclidean distance as given in the equations 10 and 11. So using these separation measures, we'll finally calculate the relative closeness values using equation 12. So in TOPSIS method, the alternatives are ranked according to the descending order of the relative closeness values. Now let us have a detailed look on Prometheus method, which is known as preference ranking organization method of enrichment evaluation. So it is one of the outranking based methods, which is based on the preference function approach. The procedure started to determine the deviations based on the pairwise comparisons. So it was assumed that alternatives were evaluated according to beneficial and non-beneficial criteria. So now let us have a detailed look on the step-by-step procedure. Similar to TOPSIS, we'll calculate the normalized matrix using the decision matrix based on equation 13. So in step 2, we'll calculate the pairwise difference of each criteria with respect to other criteria using this matrix. So from there, we'll calculate the preference function value. So if the pairwise difference value is less than or equal to 0, then the preference function value will be 0. Otherwise, it remains unchanged. So using this preference function matrix, we'll calculate the multi-criteria preference index using the equation 14, which ranges from 0 to 1. So using this preference index, we'll we'll get the living and entering outranking flows using equations 15 and 16. So from there, we'll calculate the net outranking flow values. So in Prometheus method, the fuel samples are ranked according to the descending order of the net outranking flow values. Now let's speak about the results and discussions. So first of all, we'll see AHP. Each study in the pairwise combustion matrix was compared to other using SATIS-NET and consequently the pairwise comparison procedure. So this is a pairwise comparison matrix which we used. So, here we can see the CV, BSFC, BT, CO, HC, MOX, and PO comparisons. So these are the weights which we obtained for the criteria which we used. So now the question is whether these weights are consistent or not. So this will be evaluated and assessed by consistency index and consistency ratio. So if the consistency ratio is less than 0.1, then the weights are satisfactory, which we satisfied with the value of 0.937, which is less than 0.1. Hence, degree of consistency is satisfactory, and these weights can be used for our MCDM framework. Now let us have a look on the TOPSIS results. So these are the results for TOPSIS. Here we can see that the microemulsion number 7 is ranked 1 because of the highest value of the relative closeness, and these are the Prometheus results. So here also we can see that the microemulsion number 7 is ranked 1 because of the highest net outranking flow value. Now these are the conclusions. From AHP method, it is evident that the brake thermal efficiency has more weightage for determining the optimal fuels using MCDM techniques for 100% low engine. Results obtained from AHP TOPSIS and HU Prometheus show that the microemulsion samples Me7 with 64.4% diesel, 35 volume percent butanol, and 0.6 volume percent water was found to be the optimal fuel. Hence, based on the results from the proposed MCDM work, it was concluded that considering both performance and emission metrics, microemulsions are found to be a potential alternative for diesel. Finally, I would like to thank Organizing Committee of PSC Asia 2022, IIT Madras and IIT Bombay. I would like to thank Chemical Engineering Department at Beach Plani Hyderabad campus. Finally, I would like to thank my supervisor, Dr. Arnab Datta from Beach Plani, and my co-supervisor, Dr. Armin Abrar from Beach Plani. Thank you.
Thanks, Danush. Thanks for that. Thanks for the presentation. Is there any questions that from the floor? Oh, thanks. Then that means that your presentation is well received. So we can now move on to the last speaker of today. Thanks, Danush. We should stay with this conference for the rest of the today and next 2 days.
Thanks for the opportunity.